not in the domain of this function, all right? It's not in the domain. I would want to mark it though. I'd want to realize that, you know, I can't plug this in later. Like this can't be a local max or a local min at all because you can't plug 0 in. But it does create a partition. I'm not allowed to look that way. But there might be another problem where you have something like this happen and your domain is all, you know, everything to the left is included. So let's just kind of designate that there was something happening here. But just remember, we are not going to be able to ever have a local max or min there. And then the other one is e to the negative 1/2, which on my calculator is, let's see, 0.5 negative, and then e to that. I'm getting this is approximately 0.606. So here is e to the negative 1/2. So now I need a test point. How about, dang it, 0.1? It's to the left of that. And then over here, how about 1? So I've got to plug these into the first derivative. So what is f prime of 0.1? Well, that's 2 times 0.1 times natural log of 0.1 plus 0.1. And I need my calculator. 0.1 natural log, negative 2.3 times 0.1 times 2. So this right here, now I don't know if I can do this today. I'm getting negative 0.46. And then I add 0.1. And that's still going to be a negative number. That means my original function is going down here. Oops, I forgot to partition. And then I need to plug in 1. Let me plug it in right here. F prime of 1 is going to be 2 times 1 times natural log 1 plus 1. Natural log of 1 is 0. Gone. Plus 1. 1. That's positive. Original function is going up here. Local min, I see it. So here's what I've got. I've got that f is increasing as soon as I get past e to the negative 1/2 forever. So to the right of this is a critical number. This could be plugged in. The reason this one could be plugged in is because if we plug in, right, we have a problem at 0. We knew that. But this is to the right of 0, and we know the domain has, you know, e to the negative 1/2 is in here, so we're good to go. So I plug that in, it's a critical number. It's also going to be a local min. How about where is it, local min, yeah. Where is it decreasing? From 0 to e to the negative 1/2. We have a local max. Well, there is none, because it never goes up then down. We have a local min at the point where we have to plug e to the negative 1/2 into the original function. All right, so I get to do that. Isn't that great? I'm going to erase this. Let's plug f of e to the negative 1/2 is, let's see, the original function. It's e to the negative 1/2 squared times natural log of e to the negative 1/2. All right, if I take something to a power, I multiply these two powers. Negative 1/2 times 2 is negative 1, so e to the negative 1. Times over here, these two kill each other off, right? And this pops out, so negative 1/2. And that's it. You could just write it like that. Negative 1/2 e to the negative 1. That works. You could also write it this way. Negative 1 over 2e. Because that's really 1 over e, and the e would drop down with the 2. Either way, I like this. This is kind of clean. But that's our local minimum. Now, we got to do all the same process for the second derivative. Second derivative is 0. 2 natural log x plus 3 equals 0. Okay. 2 natural log x equals negative 3. Bringing the 3 over. Divide by 2. And take e on both sides. That's the only critical number I have. This is never, oh well, yeah. Where does the second derivative not exist? Well, that's not going to happen. That's nothing we need to worry about, because the one place it's going to cause trouble is 0. And I'm already going to have that on my number line. So it's okay to just say, nah, no issues. So because I'm already putting 0 here, and that's where I have to stop, that's all right to put there. And then e to the negative 3 halves is somewhere. E to the negative 3 halves. .222? No, 0.223. This is approximately 0.223. So again, I can pick something like 0.1, and I can pick 1. Test those into the second derivative. All right, let's do the 1 into the second derivative because it's really easy. If I plug 1 in here, natural log of 1 is 0, that's gone, you get a 3. So since that's positive, that means the original function's concave up. And what about if I plug in 0.1? So I'm going to plug in 0.1 in here. 0.1, take the natural log, multiply by 2, and then add 3. I get a negative number. Original function's concave down. Okay. Thinking, hold on. Yeah. All right, so where's this thing? Where's this thing concave up? It's from here, which is a critical number, e to the negative 3 halves to infinity. Where is it concave down? Well, from 0 to here. And then, do we have an inflection point? Well, we go from concave down to concave up, and it happens here. So yes, we do. It's at the point e to the negative 3 halves, comma. Now we got to plug that into the original function. I'll tell you what it is in a second. Let me look something up real quick, just to make sure I got this right. If my computer will come on. Y'all hang tight. Okay, I just want to double check everything here. Yeah, if you do this, you'll get negative 3 halves e to the negative 3. If you plug that into the original function. All right, that's all I have time for right now. That gets you through the first section, then there's one more section. There's 1, 2, 3, 4, 5, 6 more problems, which are even longer than these. So it's a good place to stop.